Hi, this is Chong Kim, and we're going to do word search in C. Let's first take a look at the input. The input would look like this, a grid of letters followed by a list of words. The words can be found either going across, diagonally, down, up and down, or it can snake across. Alright, so let's get started. Okay, I'm going to set this up so that whenever I save the file, after I save the file, any C file, it's going to go into the shell and make the word search. And if that's successful, then it'll run it with the input. Okay, so let's make sure everything is working by just printing hello. Okay, it does print hello, but it gives us a warning saying that put s is not there, is not explicitly declared. So let's, if you're in Vim, you could press capital K, and you can get the man page, and it's coming from standard IO. So let's put that in. So now when we run it, we don't have that warning anymore. Okay, so let's take a look at the argument, and we see that we have the command line argument. I'm going to turn this into a function read file, and it's going to return a string of the contents. So read file, taking the file name, we can use fopen to open the file in read-only mode, and then after we're done, we have to make sure that we close it. And okay, so let's start with well, we have one problem. One problem is that we don't know how big we should allocate the buffer. So there's a little trick that we can try. We can use fseek with a 0 offset from the end. And then with the file size, we can use ftell to tell us what the position is of that at the end of the file. This is in terms of the number of bytes. So now we know how big that we should make our buffer. In order to read it in, we need to reset our pointer, our file back to the beginning. So we set the position to the 0. Okay, and now we can read it in. But first we have to allocate the buffer. So the buffer is, we use malloc to allocate the buffer, and it is fsize. But we're going to use fsize +1 because we want to make room for the null character. Okay, so we allocate it, now we can read it in. fread into the buffer, 1 character, fsize number of times. Okay, and when we're done, we need to terminate it by putting a null character there. Okay, so we should be able to just print out the buffer. And we have some errors. We see that malloc is implicitly defined, and it says that we should include the standard lib. So let's do that. Okay, so that would take care of this. Oh, the other thing I forgot to do is I forgot to return the buffer. Okay. All right. So we can see that the string is read in properly. The next thing we're going to do is we're going to set up our data structure. Okay, so We read the file, now we're going to parse the file. Parse the data. And we're going to pass in the data based on the string, which is in buff. Okay, so this would do that. Oh, because buff has been allocated, we should free it up. We should free the memory once we're done. Okay, so we're going to parse the data here, and so we need to specify the data. We're going to create a struct that's going to hold the data. Okay, so and that's going to look like this. It's going to hold the grid and the grid length, how big the grid is in terms of the number of rows. And we're going to keep a track of the words and the word length, how many words we have. Okay, so that takes care of the data part. All right, so now the parse data. We have the buff, and we're going to store it into the data, okay, which is a pointer. All right, so okay, so since we have the buffer, we can iterate through the buffer. So we can say, and we know when we're done when we reach an empty line. We can create a for loop that goes from buff when we're looking for new lines. Okay, what this says is it'll start from buff and updates the buff so that the next time we call it, it'll continue on from where it left off. So that would read in the first line from the string, and we're going to terminate when we reach the end of the line. So we're going to continue doing as long as it's not empty. That's what star s is doing, is making sure that the string is not empty. And we're going to continue by calling stirSep. Okay, and let's see if we're reading it properly. So I'm just going to put in a line number and the string. Let's see if the string is set properly, and we're going to keep a count, and we have the data, so we need to initialize the data first. So the data grid length is equal to 0, and every time that we find one, we're going to increment. So data is a pointer, so we have to use the arrow instead of a dot. Grid length. All right, so actually we can probably do it this way. It's better. Okay. All right, so we have a lot of problems here. First one is the stirSep. So let's get that out of the way. So stirSep is coming from string, so we should include that. Okay, let's see what the next problem is. Well, the next problem, there's no next problem. It looks like everything worked. All right. Okay, so we see that the strings are written properly. So we need to allocate the a data entry for each of those lines. We don't know how many lines we have, so what we're going to do is we're going to initially set the grid to be a null. And whenever it reaches, if the grid length happens to be a multiple of some size. We haven't defined what the size is yet. Then we're going to allocate some memory. So we're going to use reallocate. Reallocate would take the original pointer, and we need to know how big to make this. So we have gridlen already, which happens to be the previous size. Initially it's 0. Actually, we don't need parentheses here. Actually, we do, because we need to say size of a pointer, and we do this many times. The gridlen plus the size. Okay, we haven't specified the size yet, so for now let's just set it at 3, a small number, so making sure that the algorithm works. If the algorithm doesn't work, then most likely it'll give a segfault. All right. So we're able to allocate the size, and then we need to read it in. So here we're using the grid length, and every time we add 1, we increment. Okay, so it starts off 0, and then it'll become 1. Okay, so this should set up the grid, and now we can print it out. So let's handle the output for the grid. The grid is going to iterate from, let's say, the row from the grid len, and for the column, it's going to go, let's say, length number of times, and we define length to be from the row position, so it's a line on that row, and we do a string length on it. Okay, we could have just put the string length right over here, but we don't want that to be executed every time we go through the loop. So we just store into a variable first, and then just use that as a variable. All right. So now that we're iterating between the rows and columns, we're going to print out the character. But first we're going to put a separator there. Initially the separator is going to be an empty string. So the first time around there's no special marking before the character. So we put the separator and the character, and the character is going to be in the row and column position. And let's see. And then after this, then we set the separator to be a space. Okay, this has a problem. Expression result unused. Data grid. See what's going on. Okay. Oh, we forgot to assign the actual string here. Okay, so that should handle that. All right. We forgot to put a new line after we're done with the line. So let's just put a new line there. Okay, so the grid looks good. The way we're going to be doing this is by setting a high bit on the character. That's how we're going to mark it. But we have to make sure that we mask it and do all the proper things. So let's say that we have the character as the grid position, and we're going to do the test over here. When we print it out, we're going to print if, actually we could just say character, and we test the high bit. If the high bit is set, then we're going to print the character, return the character, and we're going to mask it with the with 7f, which is basically the first bit being 0 and all the other bits being 1. So when you do that, then it's the same thing as this hex value. Okay, so which basically turns it back into an ASCII character. Okay, and otherwise, we're going to put a dot. So this says if it's marked, then print out the character. Otherwise, put a dot. Right now we haven't marked anything, so we should see all dots, just like this. And if we happen to mark something, let's say for example, data grid 0, 0, and we mark that with the high bit, then we can see that 0, 0 shows the letter. So we have that set. We haven't read in the words yet. So let's go through the loop again. Same thing, except that this time around we're going to look for the comma. Okay, and we're also going to be checking for the empty string. But we also need to check if as long as this is not null. As long as the pointer is not null, because when it reaches the end of the string, it will return a null, and that's when we know we should stop. Okay. Actually, we probably don't need this, so we can probably take that out. Okay. That was necessary for the previous one because the blank line would be the condition to stop, but in this case there are no blank lines. So we have that, and we continue on with the iterative steps, which is keep going, looking for the comma, and we loop through. Okay, and we also have to set the data structure, which is the words length. We set it to 0, and the words we set that to null. And we do the same condition as before, which is if the word's length happens to be divisible by the size, then we're going to reallocate, make the size bigger. So words, size of character, and how many times? Words length plus size amount of times. Okay, so this handles the reallocation, and we just need to store the new word now. Okay, so let's take a look at this. We didn't write a print statement here, so actually let's put a print statement here. Okay. All right. We see a couple of problems with this. One is that all the grid letters are uppercase, and we also see that there are some whitespace characters, and there's probably a whitespace characters at the end. We don't know, but let's handle that anyway. So the first thing is let's handle the whitespace. So to handle the whitespace, okay, this is saying that it's incompatible. Let's see why. Words. Oh, the reason why is because it's supposed to have 2 stars there. Okay. All right, so that works. Okay. It worked before, but if we had continued on, and if it was the wrong type, then it would probably segfault eventually, mysteriously. But luckily, with these warnings, I'm able to avoid that. Okay, so we are reading the words, and we're trying to get rid of the spacing. So we can get rid of the spacing by, before we assign the string, we're going to say if it's a space. we're going to keep going. Okay, this works, but it gave us a warning. So let's go to is space, do a capital K on it, and it's coming from C type, so we should include C type. Now it's a clean compile. The next thing is we need to turn all these characters uppercase. So we're going through and assigning it, and now we can continue going through as long as it's is alpha of S, or S happens to be a question mark, the wildcard character. If that's true, then we just continue along. And when we're done, we're going to set that to be the null character. So this way, if there's any white spaces afterwards, we won't be able to see it because the string is terminated before we get there. So we've taken the print statement away. So let's put it as part of the output. So let's put a blank line in between the grid, and we run through the list of words. So that would be coming from data words len, and we're going to print the separator and the string. And the separator is just going to be an empty string in the beginning, and actually let's finish this off first. So it's the separator and that particular word. And we're going to set the separator to be comma with a space. And we can just put a new line here. See that here it is, but we forgot to uppercase that. Okay, so let's go back up here. So here we have is alpha. We did trim the end of the string of Whitespace, but we also have to say this is going to, the character is going to be to upper, so upcase that. So now we have it all in uppercase. And since we have the input taken care of and the output taken care of, we can start working on the main algorithm, the search algorithm. Okay, so which would be right here. So right now we dummied it up. Now we can get rid of it and make it real. So the way to do that is we're going to iterate through each of the words. So data.wordsLeng, and then we're going to go from the through each of the row and columns. So row, that's coming from gridlen, and we take this string length to find out how many columns we need for the grid. Okay, so now we can do it for the column for the length. Okay, so now we can just call search. We pass in the data, because the data is going to have all the grid information. We need to know the current row and column position and the current word, which is in data.words I. Okay, so that particular word. And we need to keep track of the path of where we've been. And we're going to say null to represent an empty list. Okay, so to make things pretty simple, we'll just dummy this out. So the search, it would take the data type, data, row, column, and the word, and the path. We'll call it row column type, RC type, and it's a pointer. Call it the path. Okay. And we're just going to hard code some data here. We'll say the data grid, okay, 1, 1 is going to be, the high bit is going to be set. So, okay, so that's the high bit. So let's take a look. And we see that it works. So here's the 1, 1 position, and it looks like it's working. But we have, oh yeah, we forgot to create this struct. All right, so let's do that. RC type. The RC type is going to contain the row, column, and it's going to be a recursive data structure. Next. Okay, so when we run it, okay, no more compile warnings. Okay, this is good. Okay, so now we can actually write the algorithm, since we know that it seems like everything's set up. So if we said that if we put a star in front of this, it's testing the first character to see if it's 0. We want to make sure that if it's not empty. Well, actually, this says that if this is an empty string, then we're going to go through each of the paths. So we're going to put a for loop here of the RC types, P, start with the path, and continue going as long as you still have the path that's not equal to null. And P is going to be going to the P next for the iterative step. And what we're going to do is set the high bits. Okay, so we have the grid, and the P has the row and the column information, so we can just set the high bit. Okay, we set the high bit over here. All right, that takes care of the terminating condition. Now, if the if we have the row and column in inside of the grid, so it's inbound. Okay, we test that by saying less than or equal to 0 for the row, and the row is less than grid len. And we can do the same thing for the column. So column is between 0 and the string, the line on that grid. Okay. So if the row and column are valid, and you haven't been here before, so we can say not in path, the path, and we use the row and column to check. Okay, and the letter matched. Okay, so we can, the letter matches if the word happens to equal the grid position, so data, grid, row, column. Or the word happens to be, I mean, the first character of the word happens to be a wildcard character. Okay. We've got the terminating, ending, parentheses. Okay. But we have to remember that when we're testing the character, we're setting the high bit. So in order to put this back into ASCII, we have to mask it with 7F. 7F is 0, 1, 1, 1, 1, 1, right? So it's just masking against that. We should put parentheses around these to make sure that the precedence works. Okay, so if that happens, then we should continue on. So this is the terminating condition, and this is the condition where we should keep on going. When we're outside of this condition, that means that we didn't find the match, so we can just end, and it'll just fall off this else clause. Okay, so we need to go in all directions now. So we know that this letter matched, so we have to go to the next position. And so the next position, actually, it's going to go from -1 to 1. And the column position, we're going to go from -1 to 1 as well. And then we're going to do a search. So we pass the data along the same. The row is going to be different. It's going to be row plus R. Column is going to be column. So this is the new position. And as for the word, since the first character match, we go on to the next character. And for the path, let's just say it's new path. We'll define that right here. So struct RC type, new path. That's going to be, it's going to contain the row and column information, and the next pointer is going to be pointing to whatever the path was. So this creates a linked list. Okay, so we're almost done, except that we didn't specify what in path is, so let's do that. So in path, that takes in a struct RC type. That would be the path, and row and column. Okay, so we would return if the path happens to be null, then we know that we haven't found it, so we can just return a 0. Otherwise, if it matches, we can say the path row is equal to row, and path column is equal to the column. If it matches, then we found the match, so we can just return a 1. Otherwise, we can just call in path again with the next path. So it would be path next, and we pass in the row and column again. Okay. All right, so let's see. Okay, we have some errors here. Let's fix these errors. Warning. Okay, so right. Line 65. Okay, 65. The reason why is because the column needs to be compared with the string length of that line, not the line. Okay. And and for this, this is expecting it to be a pointer, but we have a struct here instead, so we need to get the address of that. All right, so let's see. All right, so we see that everything worked, and so this has been word search in C.